Hi, hello everyone. This is Dr. Abdul Pasha. So, about this course, electrical measurements and instrumentation. So, in the previous case, we learned some basic information regarding electrical measurements and instrumentation. In that case, we discussed about course overviews and introduction and what are the basic applications and some fundamental aspects related to the electrical measurements and instrumentation case. Now today's class is about measuring instruments and their torques. What is the involvement of the torques for measuring instruments? Those are the aspects will be covered for the today's class. So usually it is associated with three torque phenomena in measuring instruments. Those are deflecting torque, damping torque and controlling torque. So these torques helps to make the pointer moves over the scale and gives the suitable results. So without these torques, we cannot able to get the accurate results and outputs from the instrument. So usually in measuring instruments, we are using these three types of torques, which are very crucial. Those are deflecting torque, controlling torque, and finally damping torque. So each torque has its own significance, according to which it can able to do its functionality and involve for the pointer to make sure about their movement according to the scale. So here coming to our deflecting torque, which moves over the scale with the help of a simple pointer. So we should have a simple pointer. This is the pointer. So with this pointer, we can able to make the movement over the scale. So this is the pointer. So which can able to move the pointer over the scale by the deflecting mechanism. So this should be associated with TD, deflecting torque. So as the force tilt the pointer to move, with the help of this development of the torque, the pointer is ready to move over the scale. And coming to your controlling torque, what it makes means it ensures the pointer to settle down in its exact position or correct reading. So once the pointer moves, once the pointer initiated, that will be moves over the scale means it is ready to settle down at a particular value. For example, this is 0.1, 0.2, 0.3, 0.4, 0.5 like that. So on, these are going to be takes place. So this pointer may settle down at this 0.5 value means this should be initiated by the torque that is known as controlling torque phenomenon. This ensures the pointer to settle down at the correct reading, exact value where it is going to stop. This should be initiated and indicated by one of the torque that is to be known as controlling torque. This is denoted by TC. And damping torque is ready to minimize the number of oscillations. Damping torque. So due to which the oscillations are produced in the pointer. So this will make sure about oscillations minimization. When pointer makes oscillations on the right and left combinations, which makes about error in reading or in sensing the case. To overcome or to avoid this case, we are using one of the torque known as damping torque, T-damp. We are using this now. So finally, deflecting torque is ready to make the force movement to move the pointer, and controlling torque to make the settle down process. And this damping torque is to avoid oscillations, minimization of oscillations. Once oscillations got minimized, then pointer can settle down its required value. So here the functionality involved for the deflecting torque is to make initiation of the movement of the point. Usually the pointer that should move from the zero value to the max value. The max value it may be voltage or current or power or energy, whatever it may be. So it initiates the movement of the pointer from zero position and indicates the measured quantity. So the cause is here generated by the quantity being measured, such like current or voltage. So not only this current or voltage parameter, we can initiate with some other factor also. So here the basic example is in moving coil instrument, deflecting torque is produced by the interaction of current carrying coil with magnetic field. How can we able to expect it to see the deflecting torque means with the interaction of the current carrying coil? So we have the CC arrangement that should be aided with the magnetic field. Magnetic field setup. Current coil is aided with the magnetic field setup, which leads to the production of deflecting torque. So this is to be associated with the parameter known as deflecting torque. Controlling torque. What is the functionality of controlling torque means? Which provides a force that opposes the deflecting torque and bringing the pointer to rest position to required position onto the scale. That means once the pointer moves over the scale, what happens means it has to situate at a required location. This instruction is followed by controlling torque, and which will settle down the pointer to the required location onto the scale. So how it can be done means this is supposed to be generated by mechanisms like spring or gravity control. We use some controlling methods for getting controlling torque, which are known as spring control method or gravity control method, which will make sure about controlling these cases, which will increasing with the deflection of the pointer, Here the purpose served is to make sure about pointer to settle down under stable condition, which will be corresponding to the measured value. That means controlling torque is equals to the product of that spring constant parameter K with the deflection theta. So Tc equals to K theta, where K is nothing but spring constant. Theta is the amount of deflection. So likewise we can able to see the controlling torque phenomena. Coming to damping torque mechanism, so which will ready to reduce the number of oscillations of the pointer and which will prevent it from swinging back and forth before settling down. So the cause produced is by various methods like air friction, fluid friction, eddy currents, which will be acting only when the pointer is moving. So here the purpose served is to help the pointer to reach its final deflected position. That should be done quickly and smoothly without excessive oscillations. That means T damp is equals to K into B square omega. This is the condition we will generate for a damping torque phenomenon, where K is your spring constant, here B is the flux density, and this omega is the number of oscillations that should be takes place for the system. Here it is about simple problem based on this torque phenomena, so whichever we discussed. So here for this we are considering a simple moving coil instruments MC. So for moving coil instruments which gives full scale deflection, this should be takes place at 15 milliamps current, and a coil is placed in a magnetic field. They are ready to produce a flux density of 0.2 T. So coil has 100 number of turns. They have effective coil area of 2 centimeters multiplied with 3 centimeters. That means these are the dimensions L and B. Now here it is about to calculate the deflecting torque under full scale condition. So we will frame the given information first, according to which what it is about to calculate, that we are ready to calculate for this case. Here it is about to ask for calculating the deflecting torque. So this should be done with these parameters. Means the first parameter is about 15 milliamps of the current. So here milliamps means into 10 power minus 3, 15 into 10 power minus 3, that we are going to consider. And about flux density B, that is about 0.2 T. And number of turns given are 100 N. The area of cross section is given 2 centimeters into 3 centimeters. So that is about 6 centimeters square. So 6 into 10 power minus 4 meters square. And deflecting torque is N into B into I into E. This is about the deflecting torque. And when you go for substitution of all the values related to which, number of turns, B value, current value, area of cross section value, all these in the given prescribed expression, we can able to get the amount of deflecting torque in Newton meters. So here N is the number of turns, which is about 100, and B is the flux density, that is 0.2. And coming to the current case, current is about 15 milliamps, 15 into 10 power minus 3. And your area of cross section will be 2 into 3 means 6 centimeters square, that is 6 into 10 power minus 4. So when you suppose to substitute all these values in deflecting torque expression, then your result becomes 1.8 into 10 power minus 4 Newton meters. So usually torque value we should consider in Newton meters. So this is the result we can able to see. And one more problem it is given with the aluminum disc, which is about diameter 10 centimeter, is placed in a magnetic field of flux density 0.1 T. So disc rotates at 100 RPM and is used for eddy current damping. So the damping torque is supposed to. What is the damping torque? Usually we will treat damping torque K into B square omega. Damping torque is considered as K into B square omega. So this is the condition for damping torque. If K is supposed to be 0.02, then what is the damping torque? Then apply the condition, substitute the values. So where K is given 0.02, before that we have to calculate omega value, where omega is treated as 2 pi n by 60. 2 pi n by 60. So 2 pi into n means number of turns are given, which is about 100. So this is the speed, 2 pi into speed 100 by 60. So here which we will get 10.47 radian per second. So damping torque is 0.02 into 0.1 whole square into 10 power 47. So this value is suitably about 0.00209 Newton meters. So this is about the result for getting the damping torque under the relation K into V square. So here the purpose served for the damping torque is to settle down the point under fixed location. We already discussed in the previous case. Now this is about one more problem. So here it is about to calculate controlling torque phenomena. Moving coil instrument has a spring with a spring constant. Spring constant is basically K. That is 0.1 Newton meter per radian. So here point of deflection is given about 30 degrees. We need to calculate controlling torque. So theta is about to calculate in radians, which is 30 into pi by 180. So pi by 6 radians. Controlling torque is K into theta. So where K value is 0.1 into theta is about to pi by 6 radians. When it is converted, given in 30 degrees in radians, so we will treat 30 into pi by 8, pi by 180. So which will give pi by 6 radians, and controlling torque is K into theta, where K is 0.1, theta is pi by 6. This will make sure about 0.0524 newtons. So likewise, these three torques are helpful in making the pointer to move and to settle down and to eliminate the oscillations produced in the instrument. So without these three torques of controlling torque, damping torque and deflecting torque, we cannot able to see the pointer to move over the scale. All these phenomena are related to only what we call analog instruments only. These are not applicable to digital instruments. So all these three torques are applicable to analog instruments, which should contain a pointer and having a scale. So by which only we can able to generate the results. None other than we cannot expect it to see all these things. So we should must have these three torque phenomena: controlling torque, damping torque, deflecting torque. Then only we can able to generate the three different torques. With that, the pointer can read the readings. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.